I'm CK. Recently I did 2 filters from a random source based on, or actually licensed from Serge, and they were pretty good, so I bought their Resonant EQ, again from random source, licensed from Serge, so it should sound like a real Serge product. So we'll put it together, put it in the rack, and see how it sounds. And I hope you enjoy the video. Let's see what we have here. We've got, where's my pointy thing? I just had it. There it is. Picked it up from thonk.co.uk, as I do many of my eurorack modules. It's got a QR code for a build document. Feels like a lot of parts in there. Probably because there's a lot of parts. I mean pots, potentiometers. If it's a EQ, probably a lot of potentiometers. But first thing, we'll look at the front panel and the circuit board, which will tell us exactly what I was just saying. It's a little wide. I noticed that on the other two, they're kind of wide. So if you have tight space in your rack, you might not have as much fun with this. But let's see. And I'm going to, here's the pots and jacks board, so we'll mate them up so we can see what we actually have here. Okay, so here's all the frequencies that we're going to be trimming to, because that's all pots. 5.2K, 11K, 1.5K, 2.8K, 411 Hertz, 77, 15, it goes real low. Here are 2 outs. I don't know why there are 2 outs, but we'll find out. And then comb 1 and comb 2, I assume that that's using these as a comb filter instead of a totalized filter. Looks like that's probably a switch. That's a pot for feedback. And then we've got okay, so that's in 1, that's in 2. Oh, and these are 2 pots, so you can set the levels of the input, so you can attenuate one of the inputs if you want to. And again, I got it all from this. This is the side that's facing. On the back, doesn't say much. The other board, it's got some sprues on here still. Clean up after yourself, guys. But as I'm looking on the back of the board, I see some surface mount pads. Now, there were surface mount pads on another one of their filters, and we didn't actually end up using them, so we'll see on this one. And then we've got a whole bunch of little stuff. Serge Resonant EQ under license from Serge. His name, I can't pronounce it because I am, as if you've watched the channel at all, you know I am reasonably incompetent with non-English names. That's my fault, not anyone else's. So we've got a bunch of resistors with all their values listed. I'm sorry, my phone's going and I gotta answer this one. I'll be back in a little bit. Sorry for the interruption. I'm donating one of my cars to charity, and I knew that was a person calling to arrange a pickup. Now, as that phone rang, if any of you can identify the song or the album that clip that is my ringtone came from, I will give you many kudos. The album came out in the 70s, to give you a hint, and it is not by a single artist. It's by multiple artists. So there you go. Guess away in the comments. And if you win, you get my admiration. So, where was I? So we've got a whole bunch of OPA 2134s. Let me look those up. OPA 2134 data sheet. I think they're specific, yeah, audio amplifiers with low distortion, low noise, and precision. That's been on the other ones. Now, I'm not sure what these are. These seem like odd capacitors, but they often lay out the board differently in unusual ways for the parts they're actually using. Because this is a capacitor symbol, but there are, as you can see, there are 4 pins. Let's look at the back there. And all the 4 pins go to the same trace. So I think it's just different size components you might get. And the date on this is 2015. And again, all the components have their values listed. So we don't need a build guide to put it together. We probably will need it to do calibration if necessary. Oh, we've got a note here, probably about substitute parts. No, we don't. Here we go. Here's some foil caps. Here's a whole bunch of polystyrene caps here. That's probably what goes in these big... No? Where do these go? These are 220s. Oh, we'll find them when we put it together. So we've got electrolytic ceramics and polystyrenes and some film caps. Lots of caps. Oh, and here we go. Resistors in individual bags. Boo! We don't like individual bags for stuff. Here's all the mechanical bits. As you can see, as we saw, there's a bunch of pots to adjust sensitivity or filtering for each individual frequency band. Let's look at the knobs, and they're nothing special. They're not grooved inside. They have no set screws. They have no metal inserts. So they're low-end knobs, which is fine. I just prefer metal inserts. Let's see what else we got in the magic electronics. Here we've got more resistors. As we saw, there's a bunch of resistors on the board. Gosh, it's going to be a long resistor time today. We should have a ferrite bead. Yeah, we got 2 ferrite beads. I saw them on the board too. Then in here, we've got 11 of those little audio op amps that they use on these Serge replica Serge redos, because they're lot lower noise threshold and all kinds of other good stuff optimized for audio. And there they all are. So I'm still not sure what these 220, are they all 220p's? No, they're not. Some of them are 47 nano, 10 nano, 1 nano. 1 nano is not much capacitance at all. And that would be the 1 nano, that's the polystyrenes. Okay, so the component holes are, like for this 1 nano, one side will go here, and depending on what polysty you get, you'll put it in one of these holes, because you may have different sizes for those. So that's it. Looks pretty straightforward for the build, just a ton of resistors. So we'll get the soldering iron heated up and start putting this thing together. Went to thonk.com to get the build guide, or actually follow the QR code on the bag to it. And as was the case with the random source filters, the build guide's not very comprehensive. It doesn't really need to be, but it's not. But it is important that you read it, because it will tell you interesting things like all these 1K resistors, none of the 1K resistors are needed. So you omit all of them. There's a picture here that's got a bunch of, like this 47K, 47 pico right here is not required. Then we've got RG1 and RG2 are 68K resistors because their value is not listed. And same on this board. These are RG, RGND, and they're 100Ks also. So you need to get the build guide, if only to see the errata, to see what's not going to be installed. So I'm going to do as I typically do, doing all the resistors first, but more importantly, I'm going to be doing one resistor live, and then we'll go quiet and fast playback, because there's not much to say about resistors. So here's all our 47Ks. I'm going to, since there's so much whatever going on here, yeah, 46.5. So I'll put one on. Let's see, where's the first one? And again, I'm double checking this picture to make sure that it's not teasing me. Okay, so that's a 4K7. Oh, these four? No, these are 47K. That was the difference. Okay, I misread the label. 47K right here. And again, the board looks good. Nice through-hole plating. And as I just found, you have to bend the leads very close to the body of the resistor to get them comfortably through the component holes. So let's see how this actually takes solder. Again, I've done two from the same lot, so I know pretty much how they're going to react. Yep, takes solder really well. Let's flip it over, and you can see that it weeped through the plated hole, making a really tight connection, and one that won't corrode. That's why we like through-hole plated circuit boards. One reason. The other reason is we could nip the solder balls off directly flat to the board if we wanted to, without losing conductivity and without damaging the solder pad or the traces. So, as I said, now we will just mute the audio, speed up the video playback, and probably cut out a bunch of this because you don't need to see all this resistor work. And let's see, playing on WQXR, the iPad app for WQXR, FM radio out of New York. We've got Strauss's String Quartet in A, Opus 2. And that's what I'll be listening to while you enjoy resistor time. Resistor time is over for this kit, and as you see, there's all these 1Ks which don't get used on this kit. And you also probably notice that many of these resistors are not flat to the board. Again, most of the hole spacing for the resistors is too small. It's as if it's set up for quarter watt, not half watt resistors, so they're up a little bit. And of course there's two of the resistors on the pots and knobs board. I also put the two ferrite beads on, because there's no reason not to. And I was a little perplexed about this cap, but it's got a very specific, there's two places it could go, and they say don't put it here. I mean, there are three places it could go. Don't put it there, put it here. So we'll be putting it there. But let's see where we are in there. I'm going to go and I'm going to put all the IC sockets on the board now, because I don't see a reason not to, and I do want to get them out of the way. And that will be kind of like the resistors. It'll happen, it'll take a while, and it's not that interesting. These are precision, the round hole style sockets. And again, rested on my pinky finger under the board. Make sure it's on flat, and that's it. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, at least 10, and there may be another one I'm missing. So again, nothing more to say here. Fast motion and no commentary. All the sockets are on, and since I'm putting the sockets on, I may as well put the pin header on, the power connector on too. It's kind of wedged tightly between these two ferrite cores, so that's not going anywhere. Now here's the 12 volt, negative 12 volt rail. As you can see, when the connector's not there, when the connector's there, you can't see that it's 12 volts, so it would be nice if they redid the board to spread that out a little bit, but since this board was designed in 2015, and that's 8 years ago now, I don't think they're going to do anything with it. So the red stripe is on that side, so we're good. And again, because it's so tightly wedged between those two ferrites, I'm not going to worry about the alignment, because it's going to be holding friction fit in there while I solder. And that's all. You might have noticed I bridged these two contacts and I solder sucked it off. You don't really need to do that on the power connector, because each pin, each pair of pins is the same voltage or ground or signal path, depending on what line it is. Now we're going to do all our boxy caps. Oh no, I'm not going to do the box caps first. I'm sorry. Changed my mind. I'm going to do the decoupling caps first, the 104s, which will go near all the... These are they 104s? Oh, these are 103s. Huh. Most people use 104s for decoupling caps. But this one, which is the same as the others, part number wise, but they want to put a 100 nano on there, so that would be a 104, but it's not a ceramic 104. It'll be how many of them do they have? It'll be a film cap instead of a ceramic cap. Don't know why. And so I don't forget, I'm going to put this 47 pico on the board at this point also. Again, it goes here. It does not go here. That spot gets left empty. I think there's an optional you can put in there, but I'm not going to do an optional. Yeah, and as I mentioned during the intro, where did I put my pointy thing? I lose it all the time. These pads are, I believe, and I'm pretty sure about this, they'll allow you to put surface mount decoupling caps there instead of those caps if you want. Okay, so that's done. Now we'll put our red box caps on. Yeah, see, this is a case that I'm talking about. This is a big 4.7 microfarad, and it doesn't fit in the two close together holes here, which might fit a disc cap. So it goes in the top hole, and as you can look on the back, let me see if I can zoom in and get detail on this. I don't know if you'll be able to see it. I don't know if it's, where's my, I gotta figure out where the pins are so I can show you. If you look, these two holes are bridged together. That's why you can use either hole for one side of the cap. So that allows them some flexibility when they order parts, and allows you flexibility if you have your own supply or a preferred vendor, or just have a bunch in bench stock. Let's see what we got here. I got 47 nanos. Now we'll get the next set of boxies. These are all 63s. Where do they go? Oh, they go over there. I keep setting this down upside down. I really don't know why. These are 100 nanos. And I've got 1, 2 as smoothing caps. And I don't see, oh, by the way, there's a 47 pico that could go here, but they say do not install that, and that's where the other 100 goes. Oh no, those are not smoothing caps. The smoothing caps are right here. Huh. I don't know what these 100 nanos are for. Where do they go? They go into the... They're in the same... Huh. That's interesting. Okay, so that's all of those. Now we'll do all our polystyrenes, polyrazzmatazz. So we'll start with 2 10 nanos. And these barely fit. These really do. I've got to put 2 side by side here. And these are so big. I'm sorry, I didn't actually check the number on that. Yes, it is. There's 2 things going on here. These are so big they barely don't fit in the space very well. And secondly, I mean, I really don't know. I'm looking at their picture. My hat came off again, and I don't want you to get blinded by my thinning scalp. I don't know how this can fit. So there's two things here. They're going to be up. There's no way I can get one of them down, but I can't get both of them down. So I got to be careful about that. And the other thing is, I can't really put the IC in there, the two ICs in there, without interfering. So I'm going to put those two ICs in now, and then deal with the polystyrene caps after I get these in place, so I'm not fighting with it later on. That's one, and the dot is on the side that's got the notch. And since all the chips are the same, and I'm just verifying this because last week I had some incorrect parts packed from another company, not this company, and not Thonk. Okay, those are in. Now I can go back to trying to fit these little guys in here, these big guys in here. And of course, the more component lead you have, the more resistance you're inducing in the circuit, and more can be more inductance too. Man, well, I'm going to have one flat and one's just kind of going to be sticking up. That's the only way that's going to work. And I do want to make sure the leads are all going straight down in the holes so they don't foul something else. That's nasty. I'm not happy with that, but there's really nothing I can do about it. Ugly, but that's what it's going to be. Now, let's see, we've got some 1Ns. Let's do the 47s. There should be, 4 N7s, I mean. There should be 3 N7s. That's 1. That's 2. That's 3. As you can see, these are also too big for the space they're given on the circuit board. But we'll live with it. It's hanging out the back, not the side, so I'm not worried about it in terms of rack space. Next, let's see what we got next here. We got these 220Js. I think there's only 2 of those. Could be wrong. I was wrong before. I picked up 68. I should have 2 of those. 680 pico. Oh, there's another 2. Oh, no, that's a different one. Never mind. I should have 2 of these. And these have both leads coming out of the end. On the 1 nanos, the 1000Js. So they're a little tricky. They could be a little tricky to put in. I'm not going to make them tricky. I'm just going to stand them up. I'm not going to lie them down, since I've already got, this is already lower than these box caps and this mess over here. So I don't care if this gets a little, if these are standing up instead of lying down. It's not going to change their performance. What are you doing? There you go. There you go, little fella. And then we should have all 220s left. Now we're going to put all the pin headers on, and we're going to do it the way they recommend. I often don't do it this way, but I may as well do it this way this time. And I'll show you what I'm talking about in a minute. I had one more. There it is. No, that's a one more 4. I need a one more. Did they not give me? They gave me an extra 4, but they didn't give me the 6 I need. And I don't think they gave me enough nail headers. Let me see. 4, 4. Oh no, they did. But they didn't give me the right. They didn't give me a 6 for here. Oh, that's. Oh, I see. Okay. Never mind. I'm wrong. You use this. You don't use a 6 in, even though it has 6 holes. You just use 4. So it was not them. It was me. Now with a couple of pins on the board, I can get rid of these. You're right, I didn't put the electrolytic caps on yet, I know. If you were wondering why you didn't see them go on yet, it's because I didn't put them on yet. Because I knew I'd be laying this upside down, and I need to take the boards apart anyway so I can put all the pots and controls on, and pots and knobs on. So all those connectors on. Now we can take it apart, and we know it'll go back together because they're all aligned. Now I will put the 2 smoothing caps in. The positive terminal is clearly marked on the board with a plus sign. Now I'm going to populate all the chips. And that is that board with various empty spots for capacitors and resistors. So again, read the build guide thoroughly to understand what you're going to omit. Now I'm going to do the pots and knobs board, but I got to turn the cameras off because battery's almost dead. Again, we've got linear and logarithmic pots, so we want to make sure we get those in the right locations. One other thing I'm going to do before I put the jacks on is I'm going to put spacers in so I can put the board on once, the front panel on once and not mess with it again. Put the screw there. One more thing. Where is it? There it is. A switch, which we'll just set in here. And the next thing we do before we put the front panel on is we look and make sure we haven't left any panel nuts on, or else that'll just frustrate us. And we did not leave any panel nuts on. So we should be all fine to settle in. Gosh, these holes are tight, aren't they? Wasn't too bad. There we go. These pot shafts are pretty tight. Now I'll get my little clamp again and clamp these, clamp this board, the front panel and the back panel, nothing moves. Making sure there's no movement. It's a little movement on the jacks. So since there's movement on the jacks, I'm going to have to push those. I'm going to have something pushing against them to keep them flat against the circuit board. So I'm going to do those first. I'll double check that I've soldered everything. Okie doke. Now we're going to mate these two boards again. Turn all the knobs counterclockwise. Put them all their panel nuts on. Now press all the knobs on. Double check they're counterclockwise because some of them moved. And get them roughly aligned with each other. I don't really care too much about that. And put our power cable in. And that's it. Ready for the rack. Here's the front, side, back, other side, top, and the bottom. So we'll go set this thing up to do its thing. Oop, I forgot the little screw for the, nut for the switch, which I can't find right this second. Oh, there it is. And now we're ready for the rack. See you in a bit. We're in the rack, and I've got it wired up. I haven't turned it on yet, of course, because what would be the fun of that? You wouldn't get to see it catch on fire if it does. So let's power it up. Now there's no LEDs on the device, so we can't really see what it's actually doing, but we can see it's drawing 89 milliamps. The manual or data sheet says it can draw up to 100. Let's see what the peak was. It was 90 peak. And on the 12 volt rail it's pulling 90 also. Nothing on the 5 volt rail, 89, and that's without doing much. So I've got all the, I'm going to take feedback all the way out. I've got all the frequency knobs set to about the middle, and we're going to have to listen how this works with our ears because I don't have a spectrum analyzer. I've got everything else, for crying out loud. I just haven't bought one yet. Get me to 1,000 subscribers and we're only 140 away, and I'll buy a frequency analyzer. So that's your goal. So let's turn this up and listen to what we got. That's from this even VCO. And I'm going to make the sequencer go through its steps. Oop, that's going really fast, sorry. But I'm going to take that out for the moment and just... Let's hear a raw signal. I'm actually going to go directly out here. I'm sorry, I did the wrong thing there. I'm going to go directly from the oscillator in with no break right now, and we'll train some of the freaks. So that's just with 11K left, and there's nothing up there. We'll go up 5.2K, bring that in. Bring that in, maybe bring in some low freak. So you can hear the differences there. Of course, it's acting like an equalizer, like you'd expect. We'll take everything all the way up. And we'll put some feedback in just for the heck of it. Actually, let me turn phase on. That's pretty interesting. Now I am going to switch it around a little bit so I can do what I was thinking of. Okay, we'll come back over here. Oh no, we don't do that. We do this over to here, and this back in here, and we'll go through a sequence. Put the clock in here. take feedback out again. And again, it works like an equalizer, like as you'd expect. Let's plug into comb for a minute. That should be more discreet. Yeah, that's actually a little bit more interesting, because that's just separating frequency bands. Give it some feedback again. Okay, comb doesn't react too much for the frequency. Take the lower frequencies all the way up. Hear that? That's pretty. Go opposite phase. And on the other one, I've got the kick drum set up. Actually, I guess that's doing the same thing. Okay. So let me bring the kick drum in. Where am I there? Out for the kick drum is going in there. I'm going to pull this out and see if we can just hear the kick drum for a bit. Take that out. I'm going to take all the high end out of this kick. I'm going to go to comb. Slow that down a little bit. I'm going to put the music, the tones back in, but take that down a good bit. So it's just color on the drum. Gonna go all the way low on that. Bring in some high. And that, again, that's on comb. Let's go back to full mix out. That's without feedback. That's with the phase reversed. I'm going to take all the low out. Let's go really fast. Okay, take it back down again. So there you go. You can see it's got basic graphic equalizing, which is fine, very handy. Even though the knobs are a little close together to work on. But feedback, when you punch feedback into there, it goes really interestingly. Though again, as I take the feedback all the way up, look, that's hitting about 111, see what the peak was, 119 milliamps, which is quite a bit, quite frankly, for a eurorack module. So there are two things about that, and I'm going to turn everything off. Even though you can still hear it, I've got some bleed going on. So, very good. The feedback circuit really makes a big difference to the equalization. And that's neat. So it's a great equalizer with good feedback to play around with. I will say it's big. You can get equalizers which fit in a lot less horizontal space, which might be more appropriate for you. But as you saw, the build is relatively straightforward. You saw with the polystyrene caps that they're kind of too big to fit on the board that they have, and they're kind of not seated the best way they can be. And if you're building this, you've got to look at the build guide to see what parts you're just flat not going to install. But it's another good one from Random Source, licensed from Serge, and it'd be a good addition. This with the two Serge filters I did, which you can look on my channel and find, or I'll put a link in the description, even though I probably won't remember to do that. Just look for Random Source, search for Random Source on my channel and you'll find it. It's a good unit, and I'd recommend it. And, as always, I hope you enjoyed the video.